Hello everybody and welcome to the Density Lab. I'm Dr. Cornelia Tilla and we're going to try to do this lab together. I know that this is an online lab and we definitely will not have any hazardous materials in this lab, but nevertheless you need to keep a professional attire and a professional method of working during those labs. For this reason, I'm required to wear a lab coat, goggles, and if you have long hair, to try to restrain it safely in a bag. For this lab, we're going to need several materials. First, some river stones for the determination of the density of the solid. Then, it is important to have a measuring cup. I find mine to Walmart. It's kind of hard to see probably, but you should have a measuring cup that show a gradation for each 10 milliliters. I think you can see it better right now. I have a small object for which I'm going to try to determine the density, a small bottle of Tabasco sauce, a bottle of water, a bottle of vegetable juice or tomato juice, or could be orange juice or any type of other juice. And of course, for the determination of density, I'm going to have a kitchen balance. And you can see that I'm going to try to put this away, probably you're going to see better. In the top of the scale, you can have the gradation in grams. That is important because those are the units of the metric system. Before starting the experiment, before using the balance, be careful to put the mass to 0. Now, the lab is going to be composed of 4 parts. In the first part, we're simply going to try to determine the density of water. In order to do that, I'm going to put the kitchen scale to 0. Alright. It is important that the red line show superimposed perfectly on the 0 line for my type of balance, but if you have an electronic balance, that should show 0. And then I'm going to measure the mass of my measuring cup. I put it in a balance and I can see a mass of 125 grams for my cup. Then I'm going to add 50 milliliters of water as precisely as I can. Okay. It is important that when you read the volume of the water, you read from the bottom of the meniscus. Also, you need to hold the measuring cup to the level of your eyes in order to avoid parallax error. So, I don't know guys how well you are able to see in this camera. The meniscus is a line between the air in a cup and the liquid. And in my case, I hope this is showing well in the camera. I don't know how clear it is. Let me turn this a little bit around. In my case, the bottom of the meniscus, it is in the top of the line for 50 milliliters. I'm going to weight the measuring cup with the 50 milliliters of water. And now I can see that the total mass is 175 grams. That means that the mass of the water that I added is 50 grams. I'm going to need to make the difference between the mass of the cup with water and the mass of the empty cup for a volume of 50 milliliters. By dividing the mass by volume, I'm going to be able to calculate the density of the water. For accuracy purposes, you need to make 3 measurements. Each time, clean and dry the cup very well. After each of measurement, please make a copy of your camera phone. That's going to be proof that you actually perform this experiment. In the second part of the experiment, we're going to try to determine the density of an object that has an irregular shape using the displacement method. So what I'm going to do, I'm going to fill my cup until I'm going to have 200 milliliters. Alright, and I don't know guys if you can see it very well. You're gonna need to read again the line from the bottom of the meniscus. In my case it is 100 milliliter. Let me see if I can have a better angle. More or less. Okay. And now I'm going to measure the cup with 100 milliliter of water. I can see that I have a mass of 225 grams. Now I'm going to add my small bottle of Tabasco sauce inside. I'm going to be sure that it's completely immersed in water. Alright, and I'm going to measure the volume. I can measure the volume and I can see that in this case I have 110 milliliters. I'm gonna weight the mass of the cup with water and the bottle of Tabasco sauce. And I see that I have a mass of 275 grams. Oh, I apologize, 250 grams. The difference in mass is 25 grams and the difference in volume is 10 milliliters. Again, by dividing the mass by the volume, I'm going to be able to calculate the density. Again, for accuracy purposes, I'm going to ask you guys to make this measurement 3 times, and each time please add a picture of your measurement with your lab report to have proof of the experiments. This concludes the first 2 parts of the experiment. For the third part of the experiment, we're going to try to determine the density of the object using the graphing method. So here I have my measuring cup, which I filled correctly with 50 milliliters of water. It's important again to read the volume of the water from the bottom of the meniscus. I'm going to weight my measuring cup with a 50 milliliter of water, and according to my balance it is 175 grams. I'm going to add river stones. You can notice that the river stones have the same density, but it's very hard to determine the volume or and they have also different shapes. So I'm going to put river stones into my measuring cup until I'm going to see that my volume is going to be 60 milliliters. Alright. When I see that I'm very close to the next gradation, I'm going to use smaller stones to be sure that I can measure the volume as precisely as possible. And now I have about 60 milliliters. The volume in my measuring cup is 60 milliliters. And I'm going to weight my measuring cup with the river stones again. Right now I can see that I have 200 grams the total mass. I'm going to need to calculate the difference in mass. The difference in mass is going to be 25 grams and the difference in volume is 10 milliliters. I'm going to divide in order to and the difference in volume is 10 milliliters. I apologize. Then I'm going to continue to add more river stones and I'm going to calculate. I'm not going to measure the second mass and I'm going to see the second difference in volume. You should be able to do 5 measurements in this way for 10 milliliters, 20 milliliters, or until 70 milliliters, 30, 40, and 50. So continue adding river stones until the total volume is 100 milliliters, and at each 10 milliliters between 50 milliliters and 100 milliliters, please record the volume. Also record the difference in mass starting with the initial mass, the mass of the cup, and with water. You're going to need to make a graph between the difference in mass versus difference in volume. The slope of this straight line is going to be the density of the river stones. To the end of the experiment, I'm going to figure out the density of the tomato juice. And for this reason, I'm going to need to start my experiment with a clean water cup, clean and dry. So the tomato juice is going to have a very different density than the density of water. So what I'm going to do, I'm going to clean and dry my cup. Very good. Then I'm going to weigh it again. And of course it's 125 grams. I know this mass from before. And I'm going to add 50 milliliters of vegetable juice. Alright. Now, it is important to notice the difference in measuring the volume between a colorful liquid and a liquid without no color. Water, it's a liquid that has no color. For this reason, you're going to see that the difference, you're going to measure the volume from the bottom of the meniscus. The tomato juice is a colorful liquid. In this case, the volume should be measured from the top of the meniscus, and I'm not sure that you are able to see very well, but the top of the meniscus, it is at the line of 50 milliliter. Now I'm going to measure my cup of 50 milliliters of tomato juice. So my balance indicate that I have 175, no, I apologize, 200 grams. 200 grams for 50 milliliters, 200 grams minus the initial mass of the empty cup that is 125 grams, that means 75 grams, and I have a volume of 50 milliliters. I'm going to need to divide the mass over the volume, and I'm going to figure out the density of the tomato juice. Again, for accuracy purposes, I'm going to make this measurement 3 times. For each measurement, please guys indicate a picture phone and add it to your lab report. To the end of the experiment, you're going to need to calculate the specific density of the tomato juice. So what you're going to do that you're going to divide the density of the tomato juice that you determine in the last part of the experiment by the density of the water that you determine in the first part of the experiment. That's going to indicate you the specific gravity of the tomato juice. Please use your data to complete the data sheet that's going to be uploaded in Blackboard. To each part of the experiment and for each of measurements, introduce pictures with your camera phone in order to be sure that you actually perform the experiment. Thank you very much for your help for doing this lab, and I can be contacted by email if you have any questions about the experiment.